In this section, we'll take a closer look at how a large language model, or LLM, understands and processes the sentence, "The sun rises in the east." By breaking down each step, we aim to reveal the inner workings of these advanced AI systems. Through the use of analogies and visual aids, complex ideas will be presented in a way that's easy to grasp. This journey will help demystify how LLMs interpret language, making the technology more approachable for everyone. Tokenization is the process of breaking down a sentence into smaller units called tokens. These tokens can be words, punctuation marks, or even parts of words, much like dividing a puzzle into individual pieces. For example, the sentence, "The sun rises in the east," becomes tokens such as the sun rises in the east. And this step is essential because it enables language models to process and interpret text in a structured and manageable way. By working with tokens, the model can more effectively analyze and generate language. Each token in a text is transformed into a numerical vector, much like assigning coordinates to a puzzle piece. These vectors, known as embeddings, help represent the meaning and relationships between words in a way that computers can understand. For example, if two words like sun and east are conceptually related, their vectors will be positioned close together in this numerical space. This process allows the model to recognize patterns and connections within language, forming the foundation for understanding context and meaning. The transformer algorithm utilizes attention mechanisms to analyze the relationships between different tokens in a sentence. By assessing which words are most relevant to one another, it can focus on those that carry significant contextual meaning. For example, it links words like sun, rises, and east to accurately interpret the intended message. This approach allows the model to capture complex dependencies and nuances within the text, leading to a deeper understanding of language. The prediction process involves the model generating text one token at a time, evaluating the likelihood of each possible next word or symbol. For each step, it assigns probabilities to various options, drawing on patterns it learned during training. For instance, when given the phrase, "The sun rises in the model determines that east is the most probable continuation. This step-by-step approach allows the model to construct coherent and contextually appropriate sentences. In the final step, the individual tokens are combined to recreate the original sentence. This process transforms the segmented pieces back into a smooth, human-readable format. As a result, the sentence, "The sun rises in the east," is reconstructed, mirroring the initial input. This demonstrates how tokenized data can be seamlessly converted back into natural language. A flow diagram presents a clear overview of the entire process, tracing each step from the initial input to the final output. This visual representation helps to demystify complex interactions within the system. Alongside the diagram, a comparative table lays out the differences between tokens, vectors, and algorithms. By examining these elements side by side, viewers can better understand how each component contributes to the overall workflow and their distinct roles within the process. Large language models have found practical uses across various industries. In gaming, they generate dynamic dialogue for non-player characters, making interactions more engaging and realistic. For branding projects, these models can quickly create compelling taglines and slogans tailored to a company's identity. These applications highlight how advanced language technology is shaping both entertainment and marketing in meaningful ways. In summary, gaining insight into how large language models operate allows us to better recognize their adaptability across a wide range of fields. Their ability to process and generate human-like text makes them powerful assets in education, gaming, branding, and numerous other industries. By understanding their underlying mechanisms, we can harness their full potential and apply them more effectively to solve complex challenges. This appreciation ultimately leads to more innovative and impactful uses of language technology.